Hello, can you hear my voice?
Hello. Hi, I can hear you.
Okay, good. So, I don't think we have a couple of minutes to check the materials or any tool in Zoom.
Your voice is breaking. Can you hear me?
What?
Your voice is breaking. Can you hear me?
I think no. Hello, hello.
Hello.
So, can you hear me now?
Yes.
Okay. So, you're asking about?
I said like your voice was breaking now. So like, is this the whole participant? Should I start now or like?
Okay. No, no, it's good. Good now. Yes, if you like that. But at first, I want to ask how the right way to pronounce your name.
Utkarsh.
Okay, Utkarsh
Mm-hmm.
Mittal. Okay,
Mittal, yes.
Utkarsh. Okay, okay. So we're gonna start now. Hello everyone, and this is Minna, and I'll be here as a tech support during the tutorial. I want to introduce you to the our tutor today, Utkarsh Mittal. He's the manager machine learning and automation at Gap Inc., and he will hold the Rise of AI, a reality check on generative AI tutorial. So I hope you all enjoy today. Thank you. So you can start now.
Okay, thank you. Just give me a few minutes. I will share my screen. Can you guys see my screen?
Yes, yes, it works.
Okay. So hi everyone. So today I'm going to talk about rise of AI, reality check. Basically, I will be going towards. So most of the people talk about Gen AI and their usefulness and productivity, but they don't talk about risk and how much, basically, how do we build those systems? What are the things that we should be taking care of when we are building those systems around, and how much when we think about economic impact that generative AI can create, but how much social and environmental impact also that it can create through hazardous CO2s and emissions. When we think about training the models, increasing the size of the model, uh, or making it more concise, and we are thinking about like retraining again and again. So how this impact the society, as well as how it creates and what is the potential of AI to create misinformation, bias, and hallucinations. Uh, so I will touch upon those topics rather than talking about more technical depths of generative AI. We'll touch on generative AI, like what is GPT and how GPT embeddings works and all those things, but will not go into like a lot of depth into generative AI, GPT stuff. A brief introduction about me. I am a manager of machine learning and automation at Gap. This is all insights I have gathered myself. So I'm not representing my company. So feel free to ask any questions in between. I think Yasmin will be moderating it. So anytime you have any questions, yeah, feel free to interject, and I will be happy to answer. Okay. So as I said, so there will be like I will be touching upon the topics of AI versus ML, like how AI is different than ML. When we talk about ML, basically we mostly talk about like supervised learning, unsupervised learning, classifications, and all those kind of stuff. But AI is some sort of a superset of ML where you have NLPs, vision, text, everything. Then we'll talk about what is generative AI, basically, what are the foundation models, which is BERT, GPT, and then what are the new things that's coming up with generative AI, like diffusion models, how do you create images, and then what other companies like Meta and uh, like OpenAI and Midjourneys and Anthropic are thinking about what kind of things they are bringing. Then next, I will shift gears and I will talk about generative AI impact, which is how much, in which sectors it will create a lot of impacts, and in which sectors there's still a lot of room to grow. And then what big tech companies are doing right now, what are the things they are planning to build, what other companies like Hugging Space, Midjourney, and they are building, what their potential is. And then what the future of AI looks like what Sam Altman thinks, the CEO of OpenAI, in next 5-10 years, what are the new modalities coming? Uh, then finally, we'll talk about risk generated by AI, which is misinformation, bias, and hallucination. I think a lot of things have been talked and curbed by like all the players now, but still there are a lot of risk of misinformation, IP thefts, and like bad actors can generate and create content, and how then we'll talk about how to create trustworthy AI. So basically, how do we create embeddings? How do we think about prompt injections? Uh, how do we think about like LLMs in terms of like uh, shortening the size of AI so that it does not create uh, basically a lot of emissions. And then I will have some concluding thoughts, also a final slide where I will talk about what are the useful resources on free resources you can actually go and look for things, and then build your intuition around AI, who are actually people who are new to this AI systems and ML systems. So how do we start with from basics and build those intuitions around which are the good platforms uh, to basically go for and then look for, and then what are the new things coming in. Any questions? Okay. Okay. So when we talk about AI versus ML, basically AI is, as I said, not ML. AI is much more than ML. AI has the ability to discover and find out new information. Uh, it has the ability to infer and to read information. It can create images, which ML cannot do it. ML is basically some sort of supervised or unsupervised learning where it basically either classify whether it's a dog or a cat, or either basically gives you a recommendations. But AI is something which can generate text, which can create new images, which can think of something which humans haven't thought about, which has a lot of billions and billions of parameters, which ML is incapable of doing it. So what are the things that we think about artificial intelligence is, which is it has ability to discover, it can infer, it can basically think about like what you're thinking about, reading information from other sources. You can send out PDFs, or you can send a video text, and it can basically give you the summary. And it has ability to reason. Basically, this is something very challenging right now because it comes up with something and which is hallucination, and but it tries to figure things out because it browses so much and so much of information from internet, and it comes up with some sort of solution which might not be applicable, but it's coming up with some solutions. Uh, so as I said, and then we have deep learning. Deep learning is a basically crux of AI, which is deep learning is all neural networks, all, and then basically ML. Then we talk about XGBoost models or like GBMs or random forest, but deep learning is basically vision models, computer vision, or or any deep neural networks. And this is all powered by then basically this is a crux of AI. Mm. So just when we look at the growth of AI over time, basically, if we look back in 200 years back, the first model that came out was a regression model, and which was only 60 parameters. And nothing happened until like 1970s and 1990s because we don't have that much compute power. Second model that came out was ARIMA, which is autoregressive moving average time series model. And then still the models were not very accurate. We have very less parameters to train. And then the backpropagation, LSTMs, uh, came out in 1997. Those are very bulky models, which has a lot of parameters, but hard to train. And because the compute was less at that time, then those models were not very reliable. Then Google came out with BERT, which is a really transformations, basically functionality or model, which basically changed the whole paradigm of AI. And this was the first foundation model for generative AI, where they were using BERT for language translations, and then GPT 2.0, which has 1.5 billion parameters. When you compare this with human brain, which is 86 billion parameters, now GPT 3.5 has 175 billion parameters, and GPT 4 has 1,000 billion parameters. So uh, these models are much more powerful than human brain, which can basically ingest a lot of information than human brain. So think about that next 5-10 years when we have GPT-5 and GPT-10 comes out, how much power they have. They have multimodalities which human brain cannot do. Then just going on the left hand side, then we have like what we have ingested in GPTs right now is reinforcement learning, which we call as RLHF, right? Which currently used for rewards and human feedback, ads optimization, promo optimization kind of stuff. Uh, then we have graphical models, which Facebook and Meta uses for their social networks and fraud detections and crime communications. Then we have foundation models for generative AI, which is attention networks, BERT and GPT. So in GPT 3.5, like at 4, where you will go if you have used ChatGPT, it asks for the feedbacks, and those are basically powered with RLHF, reinforcement learning, human feedback. And then we have graphical models. These being used now for some sort of embeddings as well when we create GPT structures. So embeddings mean similarity search, cosine similarities. Now people have started using graphical models for creating embeddings as well. Okay, so what is generative AI? Basically, Gen AI is currently there are two sets of models, which is basically large language models and image, and there will be new models coming, which is audio, image, and video image, and all those video text. So when we talk about large language models, we have basically BERT, GPT, GPT-4, and then we have image models, which is Stable Diffusion. Midjourney has also come up. But Stable Diffusion, which is first came up, OpenAI came up with basically is image generation models. Uh, so when we think about basically GPTs, these are all generative pre-trained transfers, and we'll go with some definitions of GPT. What basically LLMs do is normally there's some sort of a time series. Think about that as a time series. They basically try to predict the next word. And it mostly depends upon the quality of the data and the impact that they're trying to create. Uh, so, so when we think about pre-training and training of LLMs, basically it's mostly depends upon how much, what is the training data that you're providing? Is it clean? Is it good? It's unbiased? And all it's basically trying to come is the next word. Basically, it looks at all the probabilities and statistics, and it try to come up with what is the next word with the query. That's what you have been passing to. Okay, so what is GPT? Basically, GPT is generative pre-trained transformers. So generative means it has a bot which creates text. Pre-trained means it's basically trained on massive amount of data, internet corpus of data, like it goes into each research profiles or internet or stack overflows, and then basically it's being trained on that one. And pre kind of insinuates that there is a room that we can basically train it for specific tasks. So for example, if you want to train it for finance, then we can do it for finance, and we can just take the context of finance and train it. And then that will be the last few layers of your pre-training when you want to customize your GPT models. And then the final is a transformer-based models, which is, sorry, transformers, which is a special kind of neural networks, which is concatenated with attention networks plus feed-forward networks. And it gives you the final outcome, which is a next word, and it auto-regress. Any questions? Okay. So how GPT works? First thing the GPT does is it tries to create tokens based on the query that we are passing. So for example, in this, we have this query, the promise of large language models is that and it comes up with a new word, right? So first thing it creates those, it basically breaks down this query into small chunks of words. So the will be one word, promise will be one word, of will be one word. And then for each word, it creates a mathematical representation. So that's called embeddings. So embeddings can be any size. It can be 128, 256, 12,000, and it depends upon how much conciseness and preciseness you want in your GPTs, how much accurate GPTs you want. And then it creates this attention networks. Basically, it's a self-weight. It basically looks uh, as an internet corpus of words and find out what is the probability of each word going with each word. So it gives the models, and then models has the highest probability here. And it's basically works on the cosine similarities, or you call it as a dot product, or it can be any social networks like graph neural networks. It can come up with those attention networks. And then there is a training involved, which is neural networks, which will go slightly deeper into that one. And then there is a response. Basically, the response is the next word that it creates. And then auto-regress. Basically, it keeps on looking into each chunks and then come up with the new words. And then that's the way it creates a paragraph. Okay, so let's just look into how GPT works. And I really want to go with this GPT-3 example here. And the reason for that is when we looked at the socioeconomic impact of carbon emissions and uh, increasing the size of the GPT models, how much carbon emissions we are thinking of that we are going to inject into the space, and how much we are going to pollute it. That basically gives you an idea about it. So GPT-3, so if you look at this query that we are sending, basically it creates there is an embeddings. And with GPT-3, we have almost 13,000 embeddings vector space, which is this one. And we are almost sending 50,000 words that's being trained. So it comes out to be 6.5 billion parameters, and then 6.5 billion parameters, according to MIT Technology Review, almost like for 215 million parameters, it was 600,000 pounds of carbon emissions for one pre-training of model, which means five cars lifespan pollution that we are sending it to the environment. Uh, so think about, when you think about preciseness and training, and when you are sending queries, how much carbon emissions you are basically uh, uh, creating, how much impact you are creating on the impact when you're building those models. Uh, so how does this works? Basically, for each embeddings, these are represented into higher dimensional vector space, and then okay. Uh, and then direction of that basically decides the semantic meaning. So basically, what is the context it's being used for? And for example, water is being used for a different, or apple can be used for like maybe a food or Apple iPhone. And based on the word's semantics, basically it comes up with the direction as well as which word is it's closer to. That's what the attention networks are. Basically helps to generate the next word. Then just looking at like what is the vector space that goes into GPT. Basically, it's 50,000 parameters and then embeddings of 12,000. As I said, it's like close to 6.5 billion parameters. And when you train it, it basically it becomes huge. Okay, so this is attention networks, and the way attention networks works is basically you have query, key, and value vectors, and then when you query it, it creates key vectors and then a value vectors, and then in multi-head attentions, it's like a convolutional networks. It basically you have multi queries and multi keys and multi vectors, and then you do a scale dot product and concatenate and do a linear transformation, and then you pass into to the feed forward networks to create new responses. The final structure actually looks like this, where you are passing a query, you're tokenizing it, you're creating an embeddings, and then you have a positional embeddings, which is basically some sort of uh, where the positions of each word is. And then it goes through this attention networks, basically the self-attention, where it creates the statistical probabilities for each word, which is right now it's not a feed. At this point, it does not feed into the large corpus. And then you have a feed forward networks, which is the neural networks. And then finally, each word has to be have passed through a softmax, which is exponential values of, and then coming up with the probabilities between 0 to 1 for each word. And then it gives you the final output, which is one word. So going back to the slide, basically, this is the final architecture looks like. I basically condense into this to ease it out. But if you look, this is from the paper Attention All You Need from Google. So if you want to read, that's a very beautiful paper. That's the way they define it, how the transformer models works, and how the basically a lot of details being in that paper. So if they take the inputs, create embeddings, then they pass it through multi-head attentions, which is key query and value vector pairs, and then basically and then they concatenate and do the linear transformation, which is being passed to the feed forward networks. Okay. Any questions before we move to the impact of generative AI? Okay. So according to McKinsey, almost like what we can see is there will be almost like 15 to 40% new use cases that's being new ideas or new use cases being generated by generative AI. We almost see a 35 to 70% increase in productivity uh, using generative AI. Basically, the most of the impact is seen in sales and marketing, software engineering, and machine learning, where people have started using generative AI to create uh, images, code, and all those kind of stuff. Then we are also seeing some sort of impact on supply chains, additive manufacturing, 3D printings, risk and compliance, very in finance, basically all the 10K, 10Q reports being generated through generative AIs. It's very easy to do it, inject in Excel and all those things. And then corporate IT strategy and pricing is the least impacted by at this point by generative AI, but it can evolve and do wonders in future. A lot of room to grow. Okay. So what is big tech doing right now? OpenAI came up with ChatGPT. They also came up with the DALL-E 2, which is can generate images from text. Microsoft is rolling out Valley, which can simulate images or anyone's voice from a 3-second sample. Meta is coming with AudioCraft, which is generative AI designed especially for music and audio. And Amazon Alexa, they are basically integrating Alexa with AI Assistant, which is their premium uh, functionality, which is Alexa recommendations. And Google has come up with Bard, which is not that useful, but they are coming up with their large language models, Lambda. And Apple is also creating their own AI systems, Ajax and Apple GPT, which will be basically injected in Apple iPhones through and provide recommendations and text generations on iPhone itself. Um, so And there are this rising stars, which is Hugging Face. Right now, I think Hugging Face has almost close to 1 million models, which is all generative AI, which uh, uses different contexts to create for different purposes. Their valuation is around 2 billion. Then we have Stability AI, which is also very good in for virtual arts. Then Anthropic, which is a Claude. Claude is really good in creating a precise content. Their valuation is 5 billion. I think Anthropic and Mistral, which I did not put in the slides, they're working very closely with Google as well. And then we have Midjourney, which is generative AI focused around creating images. So basically, this is also a very intuitive way of create. You provide the text and it creates images, and you can alter the images. Very useful tool to use. So, what is the future of AI looks like? So, according to Sam Altman, who is the CEO of OpenAI and then now Microsoft, uh, then for a 4-year-old kid, they want to can have the 9-year-old information in 2 years, and 9-year-old can have 24 years old within in 7 years. They're working to add audio, video, and code modalities in Open in ChatGPTs. Then we have Facebook Meta, which is working on multimodalities. What is that means is basically you can pass sound in an image, and then image can have a sound, and image can basically can create a video out of sound. Um, so uh, and these are all regenerated images. So basically, it's very hard to decipher whether it's the original image or AI created images, as you can create any content out of just running those models and create this using these multimodalities functionalities. So AI in next 5 years, for sure, models to grow in size and sophistication. AI will be integrated in all business functions. Right now, it's Microsoft has started putting AI in all functionalities like Excel, Word, and all. We have it in marketing, finance, operations, product. Then we'll have some integrated media mix models. We can do text, images, graph, video, whatever we want to do it. Especially, it will be a game changer in manufacturing where we can provide specification requirements, constraints in 3D printing. More sophisticated plugins like Wolfram for math, Bayesian it's for reasoning. So if you want to see the what cool things that's coming into the market, you can go and look for this link, this wolfram.com, which is a really cool plugin. Better fact checks, which has started happening. There's less hallucination. I think the game changer will be AGIs, but again, there's a lot of risk posed by AGIs as well as it becomes more humanoid because AGIs is something that systems can make decisions autonomously. There is no checks and balances there. And a lot of companies are actually working on this artificial general intelligence, which does not require to be where uh, the company does not kick for training. Basically, it auto kicks for training, and then it creates a response. So this is exciting as well as a lot of it's dangerous as well for existence of humans. Then AI being used into like a lot of other things as well. For example, wildlife conservation, so counting endangered animals, neuroscience, understanding the brain, pure mathematics, unearthing connection between geometric and algebraic representations. You can use math picks and other tools. Then linguistics, discovering whale sound, or for example, for helping impaired people who cannot speak. So all those kind of stuff, AI can be used. So I want to shift gears now. I want to talk about risk. Any questions around it? Happy to take. It's almost like 30 minutes. So I think the main thing that AI and that's the checks and balances we need to keep. So first thing is like misinformation. It can influence people voting behavior. It can create hyper-realistic deepfakes, false audios, and create unease in the society. And we have seen in the news, it's very hard to detect. Right now, the current models which can detect the fake detections or deepfakes is like 50%, which is a coin toss. Then it still hallucinates is basically because it's being trained in the large corpus of data. It can create uh, text or generate response which has no meanings. Then there's a lot of bias and discriminations. Model can generate algorithmic bias. For example, a woman wearing a blue shirt can be, even she's a doctor, can be uh, basically labeled as a nurse. So all those biases are there. Then there is intellectual properties. Uh, Training data and model outputs can infringe copyrighted trademarks. It can create papers. It can create research papers. So all those things is a real challenge. Cybersecurity and adversarial attacks. It can create basically content which can be a problem or challenging for cybersecurities and create like adversarial attacks. And there's a lot of social and environmental impact as well. As I said, like as we increase the size and as we train the model, as the size increases, it creates a lot of carbon emissions and then injects into the system or into the environment. So first thing is misinformation. So everyone might have heard about GANs. Basically, GANs can create, you can pass on your images and you can create a generated image. And you can put some noise and then you can see that images are very close to the real image. And the problem with this kind of technology is you can fuse with other images and you can create an image which does just look very realistic. And there are technologies like face swaps and where you can swap someone's images or you can create video content by using or you can create avatars which looks very real. So it has a lot of potential to create misinformation and propagate through social media and really create a noise and it's very hard to control those things when it gets viral. Then we have hallucination. Basically, if we want to pass a query and then we said, oh, this, for example, in this case, I said, okay, this thing is died, but sometimes this person has died. It's basically, even he doesn't know it coming up with some sort of an explanation and trying to find out the answers, uh, uh, which is not relevant to the person. So there's a lot of hallucination and unreasonable reasoning happen because it's being trained in very large corpus of information. And what happens behind the scenes is when the model weights does not get into zeros, there is some sort of weights, and then when these weights are already there, then model just try to come up with something which basically, even though those things does not exist. In bias in generative AI, for example, there is harmful discrimination, there is exclusive norms. When you talk about a family, it gives you an answer like a family is a man and a woman who get married and have children, but not accounting for heteronormative families or children out of wedlock or single parent families. Or when it talks about harmful discrimination, it talks about two people, two blank walked in a, and then it basically assumes that it should be a Texas cartoon contest in open fire. So these are all bias and discrimination, which is basically because of the training data that we have, and it's basically get, and when you train in the large corpus of internet where the data is a lot of biasness, it basically creates that same kind of content. So challenges in detecting bias, because as I said, it's being trained on large amount of data. And auditing is very different, even though in cases of we want to pre-train it, we have to make sure the data biasness is not there. So we can do a lot of samplings and distribution when we are creating those data. We can think from like embedding space as well. There's a lot of anomalies in embeddings when we're creating, or we can monitor those embeddings. But uh, there are a lot of challenges in detecting bias, but these can be monitored and this can be basically tracked. And any anomalies and detections, basically when we are doing it, the training, we can bypass those biasness. But still, because there's a lot of data still biasness, there's a lot of human intervention is required when we are creating our own systems for detecting biases. Okay, so the other concern is the privacy and copyright concerns. So example, there are like models which can basically, you can pass on any research paper and then you can do GPT-2 and it creates a content. Because what happens is it memorizes it and it creates a context, and it can create a lot of different contexts around it, which might be very hard to detect as is it original or is it AI generated. Uh, then cybersecurity and adversarial attacks. This is, I basically took it from llmattacks.org. As you can see, so this is a prompt I passed into this GPT where I did not select for add adversarial suffix, and it comes up, I don't know. But when I basically uh, altered the text with something which it cannot basically recognize, it came up with a huge full-fledged plan how to do it. And same for the same for when I say, okay, I want to create a post which is harmful. When I did not do the adversarial profile, it basically did not give me anything. But when I added this small things, it basically came up with this whole post which I can put on Facebook or any other platforms to go get into viral and proportionate and propagate misinformation or rumors around. Then there is society, social and environmental impact. So for example, this is taken from MIT review. You can look at the parameter size as I was talking about. This is for like around 2018 or 2019. If you look at the transformer size is 213 million parameters, and it's injecting around 600 pounds of carbon emissions. There is a news from like a water crisis because of cooling of GPT systems. So Microsoft disrupted US city water supply to develop ChatGPT, and this is creating water crisis in US. Again, as we look at the training parameters and the cost to compute, which has come down from 213 million parameters to GPT-2, which is more parameters, but less compute. But again, as you see, for our transformer, um, the carbon emissions was close to 600,000 pounds. And then cost of training a transformer was $1 million to $3 million, which has come down to $12,000 to $50,000. I don't know about GPT-3 and GPT-4, but I think the cost with the multimodalities will increase a lot because now you have different sets of data, and then you're coming up with a different information. So I expect the carbon emissions as well as the cost will go up significantly. Okay. So I think the crux is building trustworthy AIs, and a lot of laws being passed by different countries, and as they were very concerned about how do we control the AIs and how do we make sure that personal information is not uh, infringed. So there's the AI Act by EU, which they started very initially, and then this Data Protection Acts and GDPRs. Then North America also came up with some blueprint, and California has their own Privacy Act and Personal Information Act. And then Asia has uh, China and Japan has also come up with some privacy and safety regulations, how to use generative AI, how to create content, and how to use. Okay, so when we are building, developing trustworthy AIs, we have to think about like how do we define goals? How do we include perspectives and ethical principles? Uh, Defining goals means transparency, means disclosing information about data sources, algorithms, models, decisions, and outcomes. Explainability is how AI systems work, the rationale behind their decisions, and the uncertainties and limitations involved. And bias and discriminations means high quality data should be used. AI systems should be thoroughly tested and validated. Outcomes should be monitored and audited, and corrective measures should be implemented. Then we have to do regular evaluation and improvements based on feedback. And these can be done either through RLHFs or reinforcement learning human feedbacks or red teamings. Uh, and results are necessary to ensure the effectiveness, efficiency, and ethically of AI systems. Then adapting AI systems to changing needs, basically expectations and context of users and stakeholders as it goes viral. Technology for fostering trust in AI, as I said, RLHF or red teamings can be used at this point, but there are other things that's like we can use other benchmarks like Stanford Blue and other benchmarks um, uh, to see how these systems are performing in terms of uh, like maintaining the trust. Okay, when we evaluate the models, we have to think about evaluations in terms of robustness, correctness, and toxicity. We have to think about prompt injections attacks, which is like someone maliciously adding bad prompts to infringe our prompts or data, or ensure AI solutions are safe, helpful, and more accessible. Then we have to think about embeddings monitoring if there's a lot of anomalies that's being injected in embeddings, which can create a lot of toxicity and hallucinations. And also the analytics for LLMs, like analyzing trends in user feedback, root cause of LLMs issues. Okay, then finally concluding thoughts, AI has a lot of potentials and exciting applications, but I think it should be used with cautions when we think about pre-training of models. We have to think key considerations include accuracy and reliability, resilience, data privacy, fairness and explanation and transparency, because these systems, as we are developing those systems, we are not thinking about it, but as these systems grow in sizes and they take control from human, it's very important that we build those systems around which has much more transparency and accuracy so that humans can completely rely on those systems. Finally, I want to just go over where you can, people who are beginners or who want to have some sort of research background, where they can learn uh, uh, like AI and ML. So they can, I think the best place to learn is Papers with Code if they want to do research kind of stuff. Then Andrew NG channels like deep learning.ai. Then podcast, this is really good one. This Week in Machine Learning. So they talk about the latest technologies. And then youtube.com, basically all these channels, Yannick, Peter, Robflow, uh, and towards data science and KD Nuggets. Yeah, these are good places to go to start with, and then learn the AI stuff. Thank you. Hello.
Hello, Utkarsh. So the presentation ending, right? Ended.
Yes, yes. I know that she's scheduled for 1.5 hours. I told her that I have a hard stop, so I'll do 45, 50 minutes.
Yes. But it's okay. So we need to end here. So thank you, Utkarsh, and it was very interesting tutorial. And thank you everyone for attending today. I hope it was very fruitful to you, and get ready for a long, fruitful journey that starts tomorrow. Excuse me, started yesterday, and that will see you tomorrow. Thank you, Utkarsh.
Thank you. Have a good day. Bye, guys. Feel free to join on LinkedIn if you have any questions. Thank you. Bye.
Thank you.